Hi, these are the tools that I frequently use with a 3D printer, side cutter, scraper, and a needle plier. The scraper and side cutter are very sharp, so sometimes when I grab it, I cut myself. So I want to make tool holders holding the tools pointing downward like this. So when I grab it, I can grab on the handles. So I will design the holder around the shape of the tools. So the shape is quite simple for the needle plier. This one requires a bit of a sketch to make these profiles. And for the side cutter, I need the profiles of the tool holder to compress at this end of the cutter so that it will be in the closed position while it's in the holder. So I use FreeCAD for making the model of the tool holder because the shape is not too difficult to model, and it could be a good tutorial for a beginner in reverse engineering. And I'm going to use a Math3 for making a 3D scan. Math3 is a single shot 3D scanner. It can scan objects like this very well without using the markers. So this scanner will use a calibrated turntable to align each scan together. For a part like this one only needs 6 scans for 360 degree scan. So I can get the result quickly, and the result from the Math3 is quite good for reverse engineering. And the parts contains metallic and black color, so I will spray it to reduce the contrast. The Math3 has the integrated computer inside, so I just use my computer as a monitor. Okay, so I will use a rubber band to hold this in a closed position, and then I'll spray it. Now I have already sprayed it, and I'm going to hold it with a clay. Stick to a clay like this. This should hold it. I need to make adjustment. Change the focus point. So next I'm going to calibrate the turntable. This is what makes the Math3 different from other 3D scanner. It uses the calibration board to precisely locate the rotation axis of the turntable. So when it scans a featureless object like this, it uses the turntable alignment instead of the tracking. And it can do this very precisely. Okay, after calibration, if I don't move the turntable and have to calibrate again, the scanner will turn the table 6 times because I set it to 6, and it will align it by using the position that is calibrated with the calibration board. So this is the method that Math3 used for aligning the object. So I will just remove the clay and move to the next part. Next part, the needle plier. Okay, the final part, the scraper. Okay, so the scanner made, all I have to do is just remove the clay and export as a point cloud. So what I do is I just click on export as XYZ. This will be point cloud format of the Math3, and merge the scan together. So the 6 scans that made will be merged into one. Click on export, and then I will continue to align the point clouds in the CloudCompare. Okay, this is CloudCompare. So I just drag and drop the files from the 3 scanner. I need to skip the first line. Click on apply. So this will be needle plier. Gonna drop in the scraper. Click on apply. Here's a scraper. Next, I'm going to drop in the side cutter. Okay, so we have everything here. Let's turn off. Alright, so we have 3 point clouds here. Let's start with the needle pliers. Use the pick 3 points to align this. This is a flat plane. I want to align this to the XY plane. So now it's aligned to the XY plane. So I'm going to rotate it along the Y-axis for 90 degrees. So now the handle is pointing toward the Z-axis. Alright, click on the check mark. And then I'm going to move this to the origin point. Okay, so the next two will be put in the same orientation as the needle ply. So the scraper also has a flat plane. So I'm going to click on the scraper, click on 3 points, 1, 2, and 3. So now it's aligned to the XY plane, the handles. Then I'm going to move it closer to the monitor. And then I'm going to rotate it along the Z-axis. I'm going to use the edge of my monitor. So now it's quite aligned. Click on the check mark. Right. Next, I'm going to flip this scraper along X-axis for 90 degrees and Z-axis for 90 degrees. Right. And then I'm going to move it so that the bottom part is closer to the needle plier. And if I look from this side, I'm gonna move the scraper to the center. You also can use the TX, TY, and TZ. You can move it just the TX. Click on none, and then you can move it 1 millimeter at a time. Just click on backward and forward. So I just move it like this. Okay, it's far enough. Click on check mark. Okay, next, the last one, the side cutter. Okay, let's align this. 1, 2, and 3. I'm gonna flip it along the Y-axis for 90 degrees. Click on check mark, and then I'm gonna move it like so. Move it one more time. This time I'm gonna put it here, right here. Okay, next I'm going to export this one by one. Click on here, click on save current entity, and save it as a PLY mesh. When you click on save, it's gonna ask you to save in binary or ASCII. I choose ASCII, and that's it. We're done. So I do the same for all 3 of the point clouds. One thing to say that the scan quality from the math tree is very good. The point cloud is very clean. Okay, using FreeCAD. Click on parametric part. Next, I'm going to import the point cloud. There are 3 point clouds that we export from CloudCompare in the PLY format. I'm going to import it one by one. Start with the needle, so it will be put in the original coordinates. Scraper, side cutter. So I'm going to change the color to a light green color, and point size change to 1. Same for all the point clouds. Change point size to be smaller. Okay, now we have point cloud in the same alignment as when we arrange it in the CloudCompare. If I want to move the scraper closer to the plier needle, I can do this by clicking on the placement, and then I'm going to move it along the Y-axis. So I can move it like this. You can use your mouse to tap on the arrow. Click on apply. I'm going to move this side cutter closer. You can move it up, down, left, right, anything that you want. Okay, after you arrange the point cloud into your desired position, I'm going to create a base of the tool holder. I do this by enable the visibility of the origin plane. We have an XY plane. I click on the XY plane, and then I click on here, create a datum plane. I will move this datum plane along the Z-axis. See, you can click on here and move it down until it reach the bottom of the base like this. So I'm gonna put it like this, about this height, and then you click on OK, and you have your datum plane here. Okay, next I'm going to create a sketch for making the base of the tool holder. I click on the datum plane, and then I click on here, create a sketch, and then you will come into the sketch mode, and then I make a rectangle box here that wide enough to be the base of the tool holder, and then I click on the sketch and click on a pad command, and then I extrude it to 40 millimeters, so it will reach the starting point of the handle here. So it's just a simple rectangle box. And next I click on this plane and click on the sketch to create this sketch, this triangle. You see here, this triangle on two sides, and I use the pocket command to cut it. So I have a trapezoid shape. Because of the scraper is much shorter than the plier and the side cutter, so I will remove some part of the solid here in this area. So I create a sketch here, just a rectangle sketch. This sketch is will be positioned just above this point of the scraper. So I use this sketch to cut the solid like this. I click on the sketch and then choose on the pocket command, cut it like this. Okay, next I'm going to create a pocket for the scraper, and I will turn off the needle plier and the side cutter because I'm going to focus on the scraper. Okay, next I'm going to create a first cut like this. I do this by creating a sketch around the point cloud. If you can see here, I just draw a sketch a little bit larger than the profiles of the scraper. It's just the line and the arc. And but before you start to extrude cut this profile, please make sure that all the lines are joined together. In FreeCAD, if the line is joined, it will show with the orange color point. See, if the point is white color, this means that the line is not joined. Okay, so you can always adjust the size and everything here. If you look from the top, you are going to see a space here between this wall and the scraper. So I'm going to fill this void with the pad command, and I'm going to mirror it to the other side as well. So I will draw just one side. I will click on this plane and create a sketch here. Okay, this will be the sketch that I create, and then I use pad command to extrude it to 6.5 millimeter. You can extrude it until it touches the scraper by moving this until it touches the scraper, and then I use mirror command. I use mirror command to mirror the extrusion from this side to the other side. This mirror command is here, and I mirror it along the YZ plane. Okay, so we are finished with the scraper. Next, I'm going to move to the needle plier. For the needle plier, I create a datum plane here. See, datum plane is very close to the one side of the needle plier. I do this by clicking on this plane and click on create datum plane, and then I offset it. So I use this arrow to move the plane. You can move it like this. Move it until it's almost touch the needle plier, and then I click on this datum plane and click on create the sketch here. Okay, this will be the sketch that I create. I just trace the profiles of the needle plier, just leave a bit of a gap, and then I use the pocket command to cut it. So I just move the arrow here. You can see here, I just move it until it touches the other side here, 9 millimeters. And as you can see here, that there is a void on this side of the needle plier, so I need to fill it. So I will create another sketch. So I just follow the profiles of the needle plier, but on the other plane, I create this sketch on the YZ plane, which is in the center of the part. I use the pad command to fill the void. I just use the arrow to move it until there is no visible line. So I have a pyramid shape pocket for the needle plier. So the needle plier is done. I think it will fit well without moving. Okay, next I'm going to move to side cutter. Side cutter is spring loaded, so I need to make a proper fit so that when I insert the side cutter, it will lock in place. Okay, I start by making the first pocket cutting. So I draw this sketch, follow the profiles of the side cutter. It doesn't have to be too close, so you can loosely drop the side cutter in without placing too much. And then I use the pocket command to cut it. So I just use the arrow to make it just passing this point. When you work with the point cloud, you can always see when the face is touching the point cloud. See here? Now it's already past the point cloud. That's why I like working with the point cloud in reverse engineering. It's quite easy and accurate. With this, I need to fill the void with a triangle shape. If you can see here, this has an opening, and I need to create a solid fill in this void so that it will keep pressing the side cutter in close position. So I do this by draw this sketch here. I draw it on a plane, pick on the face here and click on create a sketch, and I draw this sketch here. And then I use the path command. You see here, I use the path command to slowly extrude the solid and fill the void. So at 13 millimeters, it will fill all the void. Okay, next, that's be a final cut for the side cutter. So I create a sketch here on the same plane, making a small triangular shape on both sides. I mirror it, and then I use this for cutting so that it will match the profiles of the side cutter. So I cut this one, I choose cut to face. Okay, so everything is done. Okay, next will be I make a fillet here, if you can see. Okay, next will be a cosmetic. I create a fillet in the corners because I'm going to print parallel to the print bed, and if I choose a fillet, it's going to create a smooth curve. And then I add chamfer on the edges here. So this will be the chamfer, and I add the chamfer at the bottom here. I create a sketch here just to make a step so that I can change the color when I send it to the slicers. I want this area to be the same color as the handle. Okay, next I'm going to export this. I'm going to export in a step format, and then I'll open this in the slicer. Okay, here's in the Creative Slicer. I just drop the step files that we just made. I'm going to change the filament to white color, PLA. I'm going to paint it using a fill function to paint black color here and here, because the tool is in black color, and this part will be in red color. Then I'm going to use a height range, about this height, about 5 millimeter. So this will be in the black color. So the bottom part, this should be in the black color. Alright, it's all done. I'll paint up. Let's slice the plate. Almost 2 hours printing time. So black color is white, red and black. So there will be 3 colors on this part. Let's send this to the printer. DCB. Okay, I start the print. Scraper fit in quite nice. Okay, so here's a tool holder. Okay, thanks you guys for watching. I'll see you in the next video.